Hello everyone. In this video we are going to talk about formatted text files. So, until now we have only dealt with text files that are unstructured, like the novels from the Gutenberg project. However, sometimes we may prefer to keep our data in a more organized way, the same way we would prefer to keep columns of data in an Excel sheet as opposed to a Word document. In Excel we have additional functionalities such as we can copy and paste columns, sort data according to columns, hide some attributes and show other ones, and so on. So in text files, we have two big conventions to keep our data in such a structured format. The first of these is called the CSV file format, short for comma-separated values, and the other one is called the TSV file format, short for tab-separated values. These are basically text files where each line corresponds to a row of data, and the lines are divided by commas or tabs into columns. CSV and TSV formats are commonly used for distributing data that are not too big in size, so you can come across them easily when trying to download some data from the internet. Let's check some CSV examples. So if we go to GitHub, Forkser languages -list. This repository, for example, has 3 CSV files that describe certain aspects of languages. Let's check each of them, what they look like. So, one nice feature about the CSV files is that GitHub can preview them nicely. So we can see that this languages.csv file is composed of 5 different columns, 3 different versions of language code, 1 language name in English and 1 language name in the native language. The other one, languages directionality, has 4 columns. This one also includes some directionality information in the 3rd column, left to right or right to left. And the 3rd one includes information about the script of this language. So let's download these files. I'm going to get this link from this raw version. Copy the link and then use it for first changing to the directory for this week, and then wget this CSV file. Now we can see what this file looks like using less, and again in the text format we see the 4 different columns. The columns are indicated with commas because this is a CSV file. In the first line there is a header. This is a useful convention. The names of the columns are indicated, and afterwards follows the data. Each data point has the same number of columns. This is a useful convention in CSV files. So which value belongs to which column is clearly indicated. Let's continue downloading the other files. Again, I will go to raw and take the link. And the other one. So, for example, if I open this final file in Emacs, the languages script file, then I see that the first line has a missing data, but it again has the 2 commas. So I can easily see that the first value is the code, the second value is the language, and the 3rd value, which is the script, is missing here. So say if we were also missing the language name, the line would look like this, and if I was also missing, for example, the code name, then the line would look like this. So now we have seen what the CSV files are. You can, in a sense, think of them as text file analogs of Excel files. So here's a question for you. Why do we need a CSV file format, although we could potentially use an Excel file for the same purpose? Do you have an idea? Well, the answer is because although we can easily view an Excel file visually using the dedicated Microsoft Excel program, we cannot easily open an Excel file from our own program and read data from it, because Excel is a Microsoft format and it is not public knowledge how its precise format is. And what about if there's an open source analog of Excel, which there is the OpenOffice Calc. We know the format exactly, so we could potentially read data from it, but then it would be cumbersome because OpenOffice Calc is also a visual program. It keeps a lot of irrelevant details like the type, font and color of characters, which are not necessary from the point of the processing program. The CSV file keeps strictly as much as we need, which is only the actual data values for each point. The TSV files are almost exactly the same, except that the values are separated by tabs rather than commas. They can be visually easier to read if all rows have similar lengths in their columns, but they can also be more confusing than CSV files if the columns have varying length. It is in general more common to come across the CSV files, but it's also good to be aware of the other format. The commas and tabs are examples of what is commonly called delimiter characters. You can also use other delimiters like colons or semicolons for keeping your own data, but CSVs and TSVs are pretty standard ones, and you have a higher chance of coming across them in general. I would also like to add one final note about Excel and CSV files. So Excel can recognize CSV files since they are so commonly used. We can actually open one of our CSV files in Excel here. It put every value to the same column, but it's opened just as well. We can now select this column and go to data and try to divide this text into columns using the delimiter version. I'll use the comma as the delimiter. And now it's separated to different columns, and Excel is also capable of saving a file in the CSV format. So this is quite useful. By the way, there is no different option to save files in TSV in Excel, but by now we know several ways to convert a CSV file to TSV, correct? Can you think of any ways how to do such a conversion? Well, one option that immediately comes to my mind is use the tr command for translating commas into tabs. Or of course, as well, you can open the file in Emacs and just replace all the commas with tabs. That would work as well. So we said that one of the biggest strengths of CSV or TSV files is that we can work directly on them. For example, there are several Unix commands that can operate on them. This makes keeping the data in these formats very useful, so that you can easily process them later on. So now that we have some different CSV files, let's do some basic analysis on these files. So one basic analysis that comes to my mind is to check if languages.csv and languages.directionality.csv files includes the same exact set of languages. We have seen the languages.csv looks something like this, and the languages directionality.csv looks something like this. So say I want to compare these two files. How can you check if they have exactly the same set of languages? Do you have any ideas? So the first thing I would try is a very basic check. I would just check if these two files have exactly the same number of lines. Do you remember how to check for a number of lines in a file? I can use the vc.l command on languages.csv. This has 185 languages, and on the languages directionality.csv this has more than 200 languages. Then the set of languages are different. So say I want to now find the difference set between the two files. One possibility that I can immediately think is to use the unique command. Let us first combine the two files into one big file. If a language is included in the both files, it will be repeated twice in the resulting file. If it is included only in a single file, it will occur once. Then we can use the unique command to locate the languages that occur a single time. So let's first try to combine these two files in a big CSV file. But then we are only interested in the code column, because the name of the language will potentially be different between the two files because it's so non-standard. So I will remove all the remaining irrelevant columns and take only the code from this file. I can do this using the cut command. I will use comma as my delimiter and take only the first column. The result is going to look something like this. I will save this in a file called languages.cut.csv. Then I will do exactly the same for the second file. Now I'm using the up arrow to see the previous commands and down arrow to go down in this command list. So I'm here, I will go up once, up twice, and this is the command that I used to before. So now I will use exactly the same command on the second file, and the result is going to look like this. I can already see that there will be some different languages, and there's a mistake here also, and erroneous data. So I will now save this file as languages directionality cut CSV. Now I have these two cut CSV files. I want to combine them into one big data. I want the resulting file to have the number of lines that is equal to the sum of the two files. So I want to concatenate one after the another one. Can you think of easy way to do that? Well, the easiest way is to use the cat command. I will use the two files, first the languages cut CSV and then the language directionality cut CSV, and I will combine this into a languages all.csv file. Now let's view this languages all.csv file. Do you think everything went well here? This is a misnomer. Yes. Let's view the file now. So it's all fine here. There is the header from the first file, the values from the first file, and then after that begins the second file, but there is an extra line here. This is the header from the second file. I don't want this header in between my values. So one thing I can do is that I can open, of course, this file in Emacs and remove this line. Another thing I can do is I can remove that line from first, that I don't take it at all into my cat, so that header line never appears in the languages all file. So how can I do this? How can I remove the first line from a file and take the remaining of the lines? Well, I can use the tail command with the option -n, and then if I give the value +2 here, this is going to start writing the file starting from the second line, so it will omit the first line. I want to omit the first line from languages directionality cut, and this will look like this. The first line is omitted. So I will now save this file into languages directionality, say tail.csv, and then I will use this corrected file in my cat command. So I will first take languages cut and then languages directionality tail, and then combine this into languages all, which is not now going to have that erroneous header in the middle here. Okay, moving on. Now we have all the language codes in the languages all file, and we can use unique, but unique expects sorted lines. So I'm first going to sort this file into languages sorted. Let's check what it looks like. Okay, this looks good to me. And then now I can use the unique command to get the unique files using my -u argument on the languages sorted file, and this is going to give me the unique codes between the two files. If I used it with a D, this would give me the doubled codes, so the common set, intersection set between the two files. But these are only the codes. So how can I check the names of the languages? For that I can use agrep. First I'm going to save the result of this query to a different file, say languages unique.csv, and then I'm going to use this unique file as the pattern search to my egrep. So when used with the argument -f, egrep takes its patterns from this file, searches for any pattern in this file in the argument. I want to search in the languages directionality file. I have an S mistake here. So languages directionality.csv is going to give me the unique language names with one caveat. So here I see some languages that shouldn't have been in this list. So Swedish, what else? Turkish. They are included in this other file as well, but the problem is that these languages unique file has such generic patterns which can somehow occur in the middle of these lines. For example, Swedish includes an SH here, which is, I think, somewhere here. Yes. So I have more matches than I should have, because I also have partial matches. I can prevent that using the -w in egrep. That's going to search for exact words, so it's not going to match against partial words. And now I have the actual list of differences between the two files. So that's it for this video. Thank you for listening, and see you in the next videos.